in the previous session, we were discussing about the fourth chapter in physics, that is light energy. So, as we have suggested, light is the sensation of seeing different objects, right? So, light gives the sensation to see different objects. Fine. So, we discussed in the previous session about the primary colors of light, isn't it? Primary colors of light. So, what do you mean by primary colors of light? So, when you consider just a light, VII plays a very important role, right? VII, violet, indigo, blue, green, yellow, orange, and red. So, all these together give the white light. Is that clear? Right? So, white light is nothing but with your 7 different colors together combined gives the white light. Primary colors, but primary colors means any 3 colors combined together produces the white light. Isn't it? Right? Only 3 different colors, but they must be widely separated. So we choose one set as blue, green, and red. Right? Blue, green, and red. So these 3 combined together form the white light. But provided the degree of intensity must be maintained. A proper intensity should be maintained for these 3 lights, and when combined together, this gives the white light again. Okay, so this gives the white light again. So when only these 3 combined together give the white light, these are known to be the primary colors. So this is what we are actually discussed in our previous session, right? Primary colors. So why you are choosing only PGR? So actually there is a condition that they must be widely separated in the wavelength region. Wavelength region. Okay. So wavelength region for red is about 600 nanometer forward. 600 to 800 nanometer extends, but starting point I am writing nearly 600 nanometers. Okay, and for green we have somewhat around nearly around 5000 or nearly about 5500 nanometers. Okay, nearly about 500 nanometers, and for blue we have approximately around 420 nanometers. So as you can see, there is a wide gap between the wavelength range. Okay, this is approximate I have given. This is approximately 420. This is approximately about 500, and this is approximately about 600. So they are widely separated. So we have chosen this set of primary colors. So these 3 colors joined it together in a proper manner. That is, proper degree of intensity must be maintained, and with that, it gives the white color. Right? White. And as we have already discussed, white is not a color, it is just the combination of many different colors together forming the white, which is it may be either vivid or it may be either blue, green, and red. Okay, right? So white is obtained. If white is obtained only with 3 colors, then it is known to be primary colors. If white is obtained only with 2 colors, they are known to be complementary colors. We have discussed about this, right? Complementary colors. And complementary to a primary color is a secondary color. Fine. And what was the equation given? Equation. So the equation with respect to the primary colors was R plus G plus B is equals to W. Isn't it? R plus G plus B is equals to W. So red plus red light, green light, blue light combined together is giving me the white color or white light. Okay. Now we are actually interested in this particular concept, the color addition. This is a very important concept which is almost used in televisions or computer monitors. So this is very much used in television screen or in the computer monitors. Okay, so this color addition it plays a very important role. So as we have suggested that the primary colors combined together in a proper degree of intensity, white light is obtained. But when the degree of intensity is varied through a wide range, you are varying the degree of intensity of the three primary colors. Then what you observe is many unfamiliar or familiar or unfamiliar colors are going to be observed. Many different colors. White is not going to be observed in that case. If you are varying the degrees of intensity through a wide range, only for one range of intensity you observe white. But for different ranges, you will observe different colors. Okay. So this is what actually you are observing with primary colors. So when you add two colors among the three, then also you are observing different colors. So color addition, in this what we are actually doing is, we are adding the green with red. So red light and green light are mixed together. Okay, this is one of the cases. The next case is red with blue, right? Red with blue, and the next one is green with blue. So green with blue. The other combination is the combination of all the three: green, red, and blue. Proper intensity maintained gives white. Varying intensities are maintained, then gives many different colors which you may be knowing or which you may not be knowing also. Some colors we know, some colors we do not know. But many colors are going to be observed in that case when you are varying the intensity of the lights. Okay. Now, green when mixed with red, green when mixed with red gives a new color that is yellow. Green and red and green mixed together gives a new color yellow. Okay? Red and blue mixed together gives a new color called magenta. Okay? All these colors actually you will see in your drawing kit. Okay, drawing kit, the colors which you purchase for drawing. So these colors will be there, and if these colors are not there, there will be a note wherein you mix these colors. This color will be formed. You will give. Okay, so mixing these two colors, red and blue, you will get this color that is magenta. And when green is mixed with blue color, it becomes a new color known to be cyan. Cyan. Okay? CYAN, cyan. So these are the different colors obtained when these combinations are followed. Is this clear? Right. And when all the three combine together, we are observing green, red, blue together we are observing white. Now, these possibilities can be shown graphically also. These possibilities can be shown in terms of equations as well as in terms of graphical representation. So for that, let us consider the particular representation. So let me consider red to be at this point. Okay, red. Okay, then let blue be at this point. So these are all lights what we are considering. Okay, light, and let green be at this point. Okay, fine. Now, as you know, here red when mixed with green gives you yellow, right? Okay. So red I am mixing it with green, right? And you get is the yellow, isn't it? Yellow is okay. So yellow octane is when you write the equation, it becomes R plus G. Right? R plus G gives the yellow color. Okay. Next, what we have red mixed with blue. Right? Red mixed with blue gives magenta. Okay, magenta, magenta. So red when mixed with blue together gives magenta. Okay. Now the equation, if I want to write, it becomes R plus B is equals to M. So here we have R plus G is equals to Y. Right? Okay. Then we have blue and green also. Right? So blue and green together gives blue and green together gives the next color, that is cyan. Right? CYAN, cyan. And this is actually written in the equation form as G plus B is equals to C. Clear? Okay. Yes, so when you combine a red color light with blue colored light, we are observing magenta. So I have written the equation for it. R plus B is equals to M. R is red plus B is blue gives you M, that is magenta. Okay. So red with green gives you yellow, right? R plus G is equals to Y. Blue and green together gives you cyan. So G plus B equals to C. So now what we actually know, when all the three colors mix together in proper intensity, then gives you white. So red, green and blue together must give white, right? So this is nothing but white. Okay, is this clear? Right? So red, blue and green together forms the white. So equation is nothing but the same thing as written, R plus G plus B is equals to W. So this is what is the particular notation or understanding which color when combined with which color produces a new color is what we are understanding here. Red and blue together, red and blue are primary colors. So two primary colors combined gives a third color, magenta. There red and green together gives yellow, green and blue together gives cyan. So these colors which we are now observing, yellow, magenta, and the other one is cyan, right? Cyan. So these three colors are known to be secondary colors. Secondary colors. Why you are calling them as secondary colors? Because these colors are obtained when two primary colors of equal intensities are combined together. Okay, two primary colors, as you can see, red and blue combined together gives magenta. So two primary colors combined together to produce these colors. So therefore these colors are known to be secondary colors. Is this clear? Right. And now we are actually discussing about the color addition. So this gives me an information of what happens when you are adding the colors. So now these colors these addition of colors are being used in, as I have told you, the television screens or also the computer monitors. So there what actually we are observing is many pixels are there. Pixels are actually small dots which we cannot actually see, and those emit the radiations, okay, the light. Fine. So pixels are there, very small enough and very close also. So when you see a TV screen or a computer monitor, do you see dots? No, right? You see a continuous glass screen, but actually it is not a continuous glass screen. Okay, you must remember that. It is not at all a continuous glass screen. Actually, it is a form of dots like this placed very close to each other. When this is taking place, these are known to be the pixels. Okay, these are known to be the pixels, and these pixels play a very important role in the production of light on the screen. Clear, right? Now, these pixels, when we see, we do not observe them because they are much more smaller than what we can see. They are almost in the range of micro. Micro means almost 10 raised to minus 6 meters, and this 10 raised to minus 6 meters or still more smaller, it is not possible to see these sizes by our naked eyes. Clear, right? So this is what actually we observe, the pixels, and each pixel emits a particular light. When light falls on it, it emits to give you the particular color on the screen, right? So now each pixel on a monitor screen starts off with a black color. So as soon as you start the television, it is black, right? The screen is black only. It is never giving a color as soon as you start the television, right? So each pixel on the monitor gives you or starts with a black only. Then further what happens is, as green, blue and red, these primary colors, when they are at a time falling on a pixel, at a time when they fall on a particular pixel, what you observe is it gives a white color. It gives white. So you must have observed in the television screen, some part is red in color, some part blue in color, some part green in color. How is it possible? It is possible because of this phenomena known to be the color addition, addition of colors. Okay, so each pixel on a monitor screen starts out as a black. When the red, green and blue phosphors of a pixel are illuminated by are illuminated simultaneously by these colors, okay, are illuminated simultaneously, then what you observe is the white color, okay, right, white color. So this phenomenon is called additive color. This phenomenon is called additive color. Additive color. Okay, so this is the main concept used in the television screen. Now, to illustrate this particular example or to illustrate this additive color, what actually is done is you can just think of the spotlights, one red, green and yellow and blue, red, green, blue spotlights falling on the ice show. There are certain ice shows going on, right? So in the ice shows, you just imagine that three spotlights are falling and the lights are actually overlapping on each other. Spotlight means they are circle in nature, right? So now what we actually observe is, in that case, when three colors combine in this manner. So here we are observing three spotlights which actually fall on the ice and they are overlapping in this manner. Let us consider this to be red. Let us consider this to be red. Okay, this is red and this is green. Okay, let this be green and let this be blue. Okay, so now we are considering a red spotlight, green spotlight and blue spotlight. So when we look at the combination, so here as you can see, this part is only combined with red and green, this part, fine, isn't it? Okay, so this part becomes the color that is yellow. This part becomes the color that is yellow. Okay, one second. So this part becomes yellow in color. So because red and green you can observe is yellowish in color. So this part becomes yellow. Isn't it? Right. This part becomes yellow. Then here red and blue are overlapping. So this portion only red and blue are overlapping. So you can observe this color. So as you can see the color, now this is magenta, right? Magenta, and this is yellow. Then we have the next one, blue and green combined together. We observe it to be cyan. The color is known to be cyan, also sometimes called as light blue. Okay, it's just similar to a light blue only. So this is cyan, and the center one, here we are observing all the three colors combined together, so that forms the white. Is this clear? So this is white. So this is what is an example or illustration of this particular addition of colors. Okay, so this nature is being observed on the television screens or the computer monitors, right? Okay, so as mentioned earlier, the television screens or the computer monitors are examples of systems that use additive colors. So thousands of phosphor dots, thousands of such pixels together form the video on the screen, okay, from the image on the video screen. If these pixels are not present and this additive colors are not being used, it is not possible to form an image on the screen. Clear? So addition of colors plays a very important role in forming the image on a screen. Now these thousands of red, green and blue phosphorus dots make up the image and show it on the screen, right? So these dots emit light only when they are activated electronically. If you activate these dots electronically, then they start working. If you don't turn on the switch, if you do not turn on the switch, it is not possible for the dots to play their part, isn't it? When you want the television screen to turn on, what do? You turn on the button, you turn on the switch. When you turn on the switch, the television screen just starts. Initially it is black because all the pixels, they are not receiving any color, so it is just black. Then they start receiving the colors and then start emitting the colors as they receive. So while doing this, what happens? You start observing different colors, right? Different images. A person is dancing, a person is sleeping. Whatever image is observed is only because of these phosphor dots, and there are thousands of lakhs of phosphor dots on the screen which play a part in the image formation. So these phosphor dots must be activated electronically. They do not activate by themselves. Okay, right? And these red, green and blue phosphor dots that produce all colors on a video monitor, because the dots are as small as suggested, around micro level, these dots cannot be seen by your naked eyes. Okay, I cannot see. Even if I have a spectacle, it is not possible because those small sized objects must be seen through a microscope. If I have a microscope, I see it is possible, and that too with a high power microscope must be used, not our simple microscopes. Those also are not capable to show the dots. Okay, right? So now we are going to discuss about the appearance of color of an object. The appearance of the color of an object. So why the color of an object is observed? Why the color of an object is observed? Okay, so we'll discuss about this in the next session. Okay children, so let us end this session by a homework, right? So the homework for today's session is, how do you obtain the colors yellow, magenta and cyan using the color addition system, okay? Then show the graphical representation of addition of colors. Clear? So this is what you are supposed to do. So along with the graphical representation, you must also show the equation form also, right? So when red and green are combined together, you get yellow. So R plus G is equals to Y. So that equation must also be written along with the graphical representation also. Clear? Okay, thank you.